Welcome to homework.
Hello everyone, today we're doing chapter 14, problem 68, and this problem tells us that we have a compound O with this chemical formula here and this IR absorption spectra here with this proton NMR spectra shown in the question stem. What is the proposed structure of O? Well, first thing we need to do is determine the degrees of unsaturation. So we know that the number of double bonds, or the degree of unsaturation, equals the number of carbons, which is 10, minus the number of hydrogens plus halides over 2. So we have 12 hydrogens, 0 halides, 12 over 2, minus number of nitrogens over 2. So we have 0 nitrogens over 2, plus 1. So we have is 10 minus 6 equals 4 plus 1 equals 5 degrees of unsaturation. And we have an IR of 1687, so we know that we're going to have some sort of ketone, actually a conjugated ketone in our molecule. And now we need to go to the IR spectrum to understand why we say a conjugated ketone. So a conjugated ketone means that it is directly bounded to some sort of aromatic ring, such as benzene ring. So benzene is conjugated, and we have a conjugated ketone that's right off the benzene ring. And to confirm that we have a benzene ring, we should see proton absorption in the NMR spectra between 7 to 8 ppm. And we should have 1, 2, 3, 4, 5 protons. Well, let's see what we have 7 to 8 ppm. And we actually see that we have 5 protons. So we know that we do indeed have this benzene ring. Now, what else do we have? Well, we have 3 protons that are represented by, that looks like a triplet. 2 protons that are 1, 2, 3, 4, 5, 6 septet, and then we have another 2 that is a triplet. And obviously, these 5 were a multiplet, so we already accounted for those 5. So now let's see what we have in our chemical formula. Well, we use the oxygen. We use 6, 7, 7 carbons. So we have 3 more carbons. And those 3 carbons have 2 hydrogen, 2 hydrogen, and 3 hydrogens attached to it. So we can right off the bat draw 3 carbons. The end carbon will have 3 hydrogens. The middle will have 2. And this one will also have, the end will have 2 because it's going to be bounded to one of these substituents here. So now let's see the splitting pattern. Well, let's investigate these 3 hydrogens here. These 3 hydrogens are neighboring 2 hydrogens, so we should have a 2 plus 1 to give us a triplet. That's actually what we see here. These 2 are actually neighboring 2 different groups, so it has a total of 5 neighboring protons. So if you do 5 plus 1, that equals 6. That's actually what we see here. And then these N2 are neighboring, in an NMR spectra, we have the triplet, so it should be only neighboring 2 protons. So it can only be neighboring these 2 central ones. That means that on the left-hand side of it, they need to be bounded to a carbon that has 0 hydrogens. Well, we see that this carbon so far has 0 hydrogens, so we can say that this CH2 is going to be bounded to this central carbon. So it only has a total of 2 neighboring to give this proton NMR data. So if I were to do that, now we have those 2 protons. On the left has no hydrogen neighbors, on the right has 2, so we will get a triplet. These 2 central ones are neighboring 2 plus 3, 5 protons, so we get a 5 plus 1, we get 6 peaks. And then these 3 at the end are only neighboring 2, so we should get a triplet. So this is a proposed structure for compound O.